Now we'll talk about the parametric forms of the conics. Parametric form of conics. Say, let us take two functions. One is f of t, the other one g of t. Both are. This is a function of one variable t, and this is function of the same variable, but two different functions. We'll assign x for x coordinate. Assign function f of t, and then for y g of t. So we have third variable, third common variable uh, expressed expressed in both x and y coordinates. Okay, so usually for the Cartesian coordinates, this is for Cartesian coordinates. So one will be independent, and another one will be dependent. For example, say suppose you have y is equal to x function, then you have to make a table like this. um, for a given x value, what will be the value? For example, if you give 1, this becomes 1, this becomes 2, this becomes, what is that, 2. So with this you will draw a you will plot the value. So this 1 comma 1 is like this, 2 comma 2 like this. So this will be 1 point, this will be, so what you have to, this x axis will be independent and this axis will be dependent. That means whatever x you give, the y will take accordingly. So the combine together all these points, you'll get a graph. This is what Cartesian form. For the parametric form, we'll explain that. For example, if you take a parametric form of circle, usually what is the equation? Standard equation, standard equation of circle. That means your origin will be 0 comma 0. Say suppose you have unit circle. What does it mean? That is r is equal to 1. That in that case your equation will be x square plus y square is equal to 1 square. Okay, for this how do you express parametric form? This will be like this. So you have a circle, and you have the point p, x comma y, and this is r is equal to 1. So if you drop the perpendicular, this becomes 90 degrees, m 0, and then this becomes your x, this becomes your y. So in order to, so parametric form, here parameter will be theta. This we also call it as a polar form. So here now the third parameter, the common third parameter for both x and y coordinates is theta. So how do you express? So here in this is a right angle triangle. Here in right angle in triangle OPM. This is a right angle triangle. So this is cos theta. What is your cos theta? Adjacent side, x divided by 1. And what about y? Sine theta. Let us take this. This becomes This will give you x equal to cos theta, right? So if you take sine theta, then it becomes sine theta is y by 1. That means what? Y is equal to sine theta. So substitute this. So now you have x and y. This is your x and this is your y. If you substitute your equation, the standard equation, what will happen? X is cos theta whole square plus sine theta whole square. This gives you 1. So right hand side equal to left hand side. So proved. That means what? X cos theta and sine theta or the parametric coordinates in place of Cartesian coordinate. In our textbook, this theta, it varies between 0 to 0 and less than or equal to 2 pi. That means what? The circle, it will have, if you want to get the circle, you need to have all the points around this center, which is about 360 degrees. 360 degrees, which is nothing but 2 pi radians. Okay, this is a variable between 0 to 2 pi. So in our textbook there are two cases given. The suppose this is one case where your triangle, that is this triangle, this radius makes angle theta with the x-axis. In this case, if you suppose if you have um, radius equal to a and theta, and your x will be a cos theta and your y will be, this is x, this is theta, and y is equal to sine theta, a sine theta. Then if you have 0, what will happen? This value a cos theta becomes since it is 0, cos 0 is 0, then a equal sine 0 is 0, so this becomes 0. That means coordinate a comma 0 for pi by 2. This is your 0 angle theta equal to 0, and this is theta equal to pi by 2. This is theta equal to 3 pi by 2. That is, oh, sorry, this is pi, this is pi, this is theta equal to 3 pi by 2, and again theta equal to 2 pi. 0 and 2 pi are same position. If you have 0, a and 0, a comma 0, and pi by 2, cos 90 is 0, so 0, this becomes 1, so it becomes a. That means what? 0 comma a. So the coordinate the a comma 0 will be here. X equal to 0, x equal to a and y equal to 0 is the position, this position. And x equal to 0 and a equal to the y equal to a is 0 comma a. This is the coordinate. So likewise, what is happening? The direction of when you change from theta from 0 to 2 pi, the in the anticlockwise direction, your coordinates will vary. So 3 pi by pi, this pi means this is minus a, this is 0, and then minus a comma 0, nothing but minus a comma 0, this is minus a, and your y coordinate is 0. And 3 pi by 2, it becomes this a, this is minus, this 0 minus a, your 0 minus a, this becomes minus a comma 0, this point minus a, sorry, 0 comma, sorry, this is 0 comma minus a, there is y coordinate is minus a, 0 minus a. Again, if you come back to 2 pi, which is equal to 0, it becomes a comma 0, that is a comma 0. So the point what we need to note down is, the when you have theta, that is x equal to a cos theta, y is equal to a sin theta, the points will vary accordingly anticlockwise directions. This point, this is 0, this is pi by 2, 3 pi by 2, and this is the way the points will keep on will connect together in the anticlockwise direction. The second case, case 2, given is theta x equal to a sin theta, y equal to a cos theta. If that is so, what will happen? If your angle is theta, in this case you can draw your diagram will be like this. So you have x and y axis. This is your circle, and you have this point, same point p of x comma y. And in this case, the angle will be like this. That is what x equal to, this is here, x equal to a sine theta, y is equal to a cos theta. So now we'll plot theta x comma x and y. So theta 0 means what is x? That is 0. And y cos 0 1, so y becomes a. That means what? Initially 0 comma a, 0 comma is nothing but x0 and this one 0 comma a. This is the point. So the start point is here, and then if you change the angle pi by 2 90 degrees, for 90 x will be, so cos 0 is 0 and this is 1, cos 90 this is 1, so that means what? A comma 0. For 90 cos 90 is 0, so y becomes 0. A comma 0 is nothing but this point. That means what? It starts here, and then your points keep on, you will arrive the points in the clockwise direction. Similarly for pi, it will be, what is, this is the point, and this becomes your 0 comma minus a. This becomes 0 comma minus a, and then 3 pi by 2. At 3 pi by 2, this is 0, this is pi by 2, and this is pi, and this is 3 pi by 2, and then again 2 pi here. 3 pi by 2 this is exactly say 90, opposite of 90. That means what? This is minus a, this is 0, and for 2 pi it will be same 0 a. So this is what explained in your textbook. Okay, it will be, I don't know where it will be useful, but this is what explained in the textbook. Okay, now let us see the parametric form of the parabola. Y square is equal to 4x. Parametric form of the parabola, y square is equal to 4x. How does it look? So it is symmetric about y axis. That means what? Whatever value there is a symmetric about, what is that? Whatever give value you give, minus or plus, it is symmetric about x axis. This becomes your, whatever, this is plus values, this is plus y, this is minus y. All the values will be in minus. Well, if you give minus or plus, the x will always be on the positive direction. This is positive of x. That means what? X will always be positive. So somewhere here a comma 0 will be there, and this is the equation. For this, how do we arrive the parametric equation? The basically the parametric equation. So the we have to assign x some value, we need to assign, and corresponding y value we can get it. So the objective is common variable need to introduce in both x and y. Here y square is equal to 4ax. So the objective like this, it will be like this. If you take square root, so how do you arrive the y? It will be is equal to root of 4ax. If I take 4ax, if yeah I will, so I need to assign value for the x such that if you take the square root, I need to get an absolute value. So what should be the x value in that case? So it can be some square, if you take square root, some absolute number has to come. How does it come? So then basically now we have 4 as a 2 into 2. and a we need another a to get rid of square root. So that will be introduced in the x. Okay, and some third variable has to be introduced. Here the variable will be t, which is a real number. The real number means it will be negative. It can be a negative or positive. So I will introduce t square. Okay, so this is your x. So with that, what is the advantage that we are getting here? We'll get y is equal to 2 come out, and then a into a come out, and then t square it will come out. So your y will be 280. So for the Cartesian, for the Cartesian form of parabola, y square is equal to 4ax, x equal to at square, y is equal to 280, or the parametric coordinates. So if you say parametric coordinates, you need to represent like x comma y. P of x comma y will become p of at square and 280. Suppose they are asking parametric equations, then your answer will be x equal to at square, y is equal to 280. Now we have seen one form, that is y square is equal to 4x. Suppose if your equation is y square is equal to minus 4ax, what would be the coordinates or parametric equations? So again you have to take same, y is equal to root of minus 4ax. So minus root of minus, and it is an imagined number which is not existing. So it's imaginary, is not a solution. So for that, what we need to do, we have to introduce minus. So minus 2 into 2, and a will be there, and your x will be, you need to have one minus and then another a, and then t square. So this is what your x coordinate. So with that, what you will arrive, you will get y as, again this minus and minus plus, then it's 2, this come out 2, and then a into a, one a will come out, and then again the same t. So in this case, your coordinates, parametric coordinates equal to minus 80 square and 280. This is very that is obvious. The how it is obvious, because earlier our parametric y square is equal to 4x is this side, and y square is equal to minus 4x will be like this. Okay, vertex will be here 0 comma 0, and here it is focus, there is way minus a comma 0. Then this any point on this p x comma y can be represented as p of minus 80 square to 80. This is nothing but this side it will be x positive, and this side x will be minus, so negative. That is why we have introduced a negative sign here. Now we have two more. What are they? One is x square is equal to 4ay, and another one x square is equal to minus 4ay. So similar way, x equal to root of 2 into 2a, and then your y should be some parameter which is a, and then t square. So this becomes your y. This becomes your y. Now your x will be that out of 2, 1 2 will come out, a and a will come out, and then t. Now x equal to 280, and your this is your y, right? This is your y, this is your x. So now the coordinates will be, parametric coordinates will be, x will be 280 and y will be 80 square. Similar way, x equal to root of minus 4 into y, x equal to root of minus 2 into 2 a, and then for minus 1 minus, and then a, and then t square. That means what? Your x will be your this is your y, and your x, it is x equal to 280, right? So again here it will be 280 and minus 80 square. So this is what you need to notice. Here it is positive, this is negative. Now the equations and how does the graph looks? Graph will be like this. So x square is equal to 4ay means whatever negative and positive values of x, it will be positive only. So your parabola will be like this. So this case it will be the reverse. It will be like this. Whatever plus or minus x values you give, always y will be negative. This is a negative y, and this is positive y. So this is positive x axis x, this is negative x. Okay, so now you understood well. This p will be 280 80 square, and your p here is nothing but 280 minus 80 square. So now if we have a table like this, the y square is equal to 4ax, the coordinate parametric coordinates will be 80 square 280, and your parametric equation will be this will be equal to x and this will be equal to y. That is what equations. And similarly y square is equal to minus 4ax, it will be minus 80 square, the x coordinate will be minus. And so that the same, the x and y equate to x and y. That will be your parametric equations. For x square is equal to 4ay, it will be the reverse of this 280 80 square. And if you have minus x square is equal to minus 4ay, the equation y coordinate become minus 80 square. So same this equations. So it is very well understood. So if you have a problem which is very similar to this, and you have the corresponding parametric coordinates, and you have parametric equations, very simple. So you need to see that square root give the real value, that is the main objective. And your t, it varies between minus infinity, uh, this is main important. So your t will be varying like minus infinity to plus infinity. This is what main important. The t is real variable, real value variable. It can be from minus infinity to plus infinity. Now let us see the parametric form for ellipse. Parametric form for ellipse. So what is our Cartesian form? X square by a square plus y square by b square equal to 1. So we'll actually what is ellipse? Ellipse is nothing but ellipse we can obtain from our standard circle by stretching and squeezing x and y axis, or alternatively x and y axis or y and x axis axis. Okay, so how does it happen? So suppose if you take a circle, if you have a circle like this, and you can squash this direction, and you'll get like this. That means what? This direction, it has been stretched by a factor a, and this way we are squeezing in this direction, squeezing by a factor b. So that is why this coordinate is a, and this coordinate is b. So how do you arrive from the what is our standard equation? V of circle, standard equation of circle x square plus y square is equal to, say suppose this is a unit circle, 1 square, which is 1, again 1. So what we are doing, what is our parametric equation? Parametric coordinates of circle, that impart cos theta and sin theta. These are the coordinates, parametric coordinates of the circle, this circle. So we have seen there is a stretch and squeezing by factor a and b. So what we'll take, we'll include a cos theta and uh, b sin theta here. So this is stretched by a units and this is squashed by b units. So this is your parametric coordinates. We'll see that whether it satisfies our equation. Our equation is x square by a square plus y square by b square is equal to 1. If you substitute this as x and y, what will happen? A square cos theta square divided by a square plus b square sine square theta divided by b square. So b square cancels, a square cancels, and you have sine square theta, cos square theta plus sine square theta, which is nothing but 1. So this is LHS, this is your RHS. Since RHS equal to LHS proved. That means what? So these are the coordinates. So these are the parametric coordinates for your ellipse. Just by simple logic, we have arrived that a cos theta, b sin theta are the coordinates for the ellipse. Now we will arrive about the parametric parametric form for the hyperbola. Parametric form for hyperbola. So what is the Cartesian coordinate? Cartesian form is x square by a square minus y square by b square is equal to 1. We'll go with the same circle too, since we have used circle squeezing and stretching from circle to ellipse. So like that we'll see that standard circle, again we'll take standard circle equation. Center 0 comma 0 and radius equal to 1. That's nothing but x square plus y square is equal to 1. How it has been arrived? So there is a circle and we have point P, x comma y, and connected. This is r equal to 1 and dropped one perpendicular m OPM. Now this is your angle, and this is a right angled triangle, which is nothing but x equal to cos theta and y is equal to sin theta, right? So similar way here, let us consider this triangle. Since you have a triangle like this and 90 degrees, here your x is here, your y is here, and here is 1. The same way here, if you take this circle, take away this stretching and squashing. So if you take these factors out, what will happen? Still x square minus y square is equal to 1. This is the equation. Okay, this equation, what if you modify this, just manipulation, 1 plus y square, how does it look? This is looks like this can be represented in a triangle, that is where your hypotenuse is x and you have the y here and 1 here. Okay, here is your angle. So what is your cos theta here? Equal to 1 by adjacent side by hypotenuse. What is your tan theta? Opposite side, y by 1, that is opposite side by adjacent side. So if this is 1, so from this we can arrive x, right? From this we can arrive y. So what is your x? X is nothing but 1 by cos theta, which is nothing but secant theta. And here it is y is equal to tan theta, right? So if you substitute these x and y, let us see that whether we are arriving LHS. So our LHS is x square by a square minus y square by b square. So what is that? So x is nothing but a secant square. So now again we need to introduce stretching. This is a secant theta and this is b tan theta. If you take like that, so this becomes a secant square theta. This is a square minus b square tan square theta divided by b square. So if you cancel this, a square b square cancel, and you have secant square theta minus tan square theta. What is this? This is 1. So your LHS is 1, which is equal to RHS. So proved. So in our textbook, this is the table given. So circle will have parametric coordinates x equal to a cos theta, a sin theta, where your a is radius, and your third parameter, that is a third common parameter, is theta. Range of parameter which will vary between 0 to 2 pi, because the entire circle, the angle formed at the center will be 360 degrees, which is equal to 2 pi radians. And theta, any point on the conic, theta, if you take angle as a input, and you will get the x and y output, corresponding output x and y. Parabola x equal to 80 square, y is equal to 280. This is for y square is equal to 4ax, and your common parameter is t. This t varies between real values minus infinity to plus infinity, and t or 80 square to 80. Okay, any point on the parabola will be 80 square to 80. Ellipse, because a is a constant for a given parabola, a is a constant and the variable is t. Ellipse, if you take the same circle, a cos theta, b sin theta, here a cos theta, a sin theta, here it becomes a cos theta, b sin theta, and your theta varies between 0 to 2 pi radians. And theta, you have a and b, which is a major and mini axis, semi major, semi minor axis, and theta is the variable between which varies between 0 to 2 pi. For hyperbola, x equal to a secant theta, y is equal to b tan theta, and your parameter is theta, and this varies between minus pi to pi, because there is a this is because the theta equal to pi by 2 means your secant theta, which is nothing but cos theta, 1 by cos theta, that is 1 by pi by 2 pi cos theta, 0 0. So this becomes infinity, so it's not defined at pi by 2. And also if you take this is x coordinate, for y coordinates b tan theta, 1 by there is a sine pi by 2 divided by cos pi by 2. What is sin pi by 2? This is 1 by 0. This is 0. So again minus. So only except this theta equal to plus or minus pi by 2, it is not defined, and you have minus pi to pi. Okay. That is because you have the parabola, the hyperbola like this. One will be like this, the another one it will be like this, and your directrix will be somewhere between center and the vertex. So it is not defined in the there is a pi by 2, this is pi by 2, this is my pi by 2, this is your pi, and this is minus pi. So the values are defined only in the between minus pi to pi, not in the pi by 2, plus or minus pi by 2. We will look into the tangents and the normal to the conics. Tangents and normals to the two conics. So basically the tangent, what is tangent? It is a straight line having only one point of contact with the curve. Okay, and what about the normal? It is also a straight line passing through the same contact point. but perpendicular to tangent. Okay, perpendicular to tangent. This is key point. Same contact point and straight line having only one point of contact, only one point contact with the curve. Okay, so this is the meaning of the standard tangent and the normal. So let us look into the first equation of tangent in Cartesian form. For parabola y square is equal to 4ax. So how does it look? This parabola will look like this. This is your y-axis, this is symmetric about x-axis. This is your y square is equal to 4ax. So positive y-axis, and this is negative y-axis, this side x-axis, which is always positive. So whether you give positive values of y or negative values of y, always you will have positive values of x. So y, if you plug in y values that are positive and negative, you will get always x as a negative. So that is the interpretation of this curve. So here the how the approach, the how do you arrive this tangent in Cartesian form? So first of all, there is something called as here when you cut 2 points, this curve, let us say this is P, this is Q, and P is having x1 y1 point, and this is x2 y2. So generally if you cut a line, this curve at 2 points, then we call it as a secant line or chord. Okay, chord generally in the case of a circle, but in general terms, okay, secant line. If you have 2 points, you can okay, let us take since these are the 2 points on the curve, we can plug in these 2 points on the curve. So if you plug in x1 y1, let us y1 square is equal to 4a x1. So this is the plugging point P in the curve. So it will satisfy, if the point is on the curve, it has to satisfy the equation. This is first equation. The second, if you this y2 square is equal to 4a x2, again it is q of x2 y2 point on the curve. So you have two equations. Okay, so what I'm doing is let us subtract 1 from 2. So what will happen? Y2 square minus y1 square is equal to, on the left hand side, on the right hand side you will have a common, and x2 minus x1. So if you this is a square minus b square, so you can split it into y2 plus y1 into y2 minus y1 equal to 4a into x2 minus x1. So if you keep y2 minus y1 on this side and bring this x2 minus x1 on the left hand side, you will have 4a by y2 plus y1. So the process, so how do you see, we have the line. See, someone can can draw a line passing through 2 points. It's very easy. So in order to get the tangent, you should have only one point. So let us say we are going to draw the tangent at this point. So how does it look? It look like this. So in order to get a point on the tangent should have only one point. So naturally you should there should not be any q. So what we are going to do, we will bring this point along the curve such that it vanishes, and p and q becomes one point. So that means what? If q, suppose q tends to b, it is coming towards p, then what will happen? So your x will be same, x1 and x2 will be same here. So if you have this, so this portion is a slope of that line. Okay, and if you consider this side, then if y2 equal to y1, if q tends to p, if q comes to here, and naturally what will happen, this y1 and y2 will be equal. So in that case what will happen, this is the slope of line, secant line, which is equal to, now it becomes tangent. So 4a divided by 2y1. So 2 ones are 1, 2 2s are. So 2a by y1 is your slope of tangent. Because q becomes p means only one point, that is nothing but this tangent. The slope of tangent is 2a minus. If you have, so from the recall from analytical geometry, the slope and a point, if you are given with a slope and point, you can easily construct a straight line. So what is that straight line? You will be y minus y1 equal to m into, so m into x minus x1. So y minus y1, our m is this one, right? So m is 2a divided by y1 x minus x1. If you multiply with this, it will become y into y1 square 2a into x minus x1. So y into y1 minus this y1 then goes that side, then it becomes 2ax minus 2a x1. This becomes a plus y1 square. If you substitute y1 square is equal to 4ax1. So y1 equal to 2ax minus 2ax1. This becomes 4ax1. That means what? y1 equal to 2ax. This is minus 2ax1 plus 4ax1. That becomes 4 2ax1. So y1 equal to 2a common x plus x1. So this is the equation of tangent in Cartesian form. Okay, if you have directly p1 here. So now we can derive, this is a Cartesian form, the equation of tangent in Cartesian form. We are given with the px1 Cartesian form at a point px1 y1, right? So if you want to find, so let us find tangent in parametric form. How do you find that? So this can be find. So your point will be p of x1 y1, that will be p of at square 2at. So this is your parametric coordinates. If you substitute that, y1 equal to 2a into x plus x1. This is x1, this is y1. So y into y1 is 2at equal to 2a into x plus at square. So if you see that, you have 2 common, a common, 2 common, a common. So then in your equation becomes yt is equal to x plus at square. So this is what your equation of tangent in parametric form. Tangent in parametric form. Now we'll see. Now we will arrive normal to the parabola. Y square is equal to 4ax. So the tangent slope is 2a by y1. So you know from analytical geometry, if there are since the tangent and normal are perpendicular, their slopes are their slopes product equal to minus 1. That is m1 into m2 equal to minus 1. So if you take as a tangent slope as m1, so 2a by y1 into m2 equal to minus 1. Then your m2 is equal to y1 divided by 2a minus. This is your slope of normal. So you know slope and you have the point. Then you can directly write the straight line equation. It is also straight line, right? Straight line equation with the m2 and p of x1 y1, same point, contact point. So y minus y1 equal to minus y1 divided by 2a into x minus x1. So what will happen? So this a 2a multiply 2a into y minus 2a into y1 equal to minus y1 x, and then minus minus plus, this becomes y1 x1. So if you take so x and y on one side, this is your x, so this becomes x y1, and then y plus 2ay, this is equal to, this goes this side, and it becomes so y1 y1 x1 plus 2a y1. So it's nothing but x y1 plus 2a y equal to, if you take okay, that's all. This is enough. This is your normal equation in Cartesian form. Now we'll arrive with the parametric form. Same procedure. Parametric form. How do you obtain the parametric form? With 80 square, 280 as a point. So substitute x into y1 is 280 plus 2ay equal to y1 is 280 x, y1 is 280 into 80 square plus 2a into y1 280. So what you can do? So take the common, everything common, this goes, this goes, this goes, this goes, this goes, this goes. So now your equation will be this y, you keep it as such, and this becomes xt equal to, this is at square and t multiply together, at cube plus 280. So this is your normal equation in parametric form. Now we have a theorem. The theorem says that three normals can be drawn to a parabola y square is equal to 4ax from a given point. One of which is always real. Is nothing but, you can draw the parabola, and if you have any point alpha plus beta, alpha comma beta, you can draw normal like this. These are the three normals, and out of which one will be real and other two will be imaginary normals. That is what this theorem is telling. We can prove that. So we know that what is the equation. So the parabola equation is y square is equal to 4ax, and the point of contact, point of the point, no, not the point of contact, the point from which we can draw the normal, and the point from which we can draw normal, or normal is alpha plus alpha and comma beta. So we know that what is the equation of normal? Equation of normal in parametric form. That is y is equal to minus ttx. So this this one, we are bringing xt to the right hand side. So then it becomes minus tx plus 2at and then plus at square. Okay, so if m is the slope, so here it is very similar to the y is equal to mx plus c. So if you compare these two equations, your slope will be minus t. If you have slope, I can rewrite as t is nothing but minus m. So if you replace t with minus m, then your equation becomes, so substitute this one into this one, then it becomes y is equal to minus m minus becomes mx minus 2am minus am cube. So the equation like so in terms of m, so rearrange in terms of m variable, then it becomes am cube, bring it that this side, and then plus 2a. So before that we want to do one thing, so rearrange the term and then substitute. So since alpha beta is alpha comma beta or the point is the point common to all the three normals, we can substitute in the normal equation above. Then it becomes y, in place of y it will be beta, and then m alpha minus 2am minus am cube. So this can be rearranged in terms of m cube, rearrange in m, that means am cube plus 2a minus alpha into m and then plus beta. So that is what so the highest degree is 3, so there will be 3 solutions or roots, whatever it is. Okay, so you heard of cube root of unity. This is nothing but omega cube minus 1 equal to 0, and then if you solve you'll have omega 1, omega 2, omega 3. So out of which one will be, say suppose this is 1, the value will be 1, and these two are conjugate of imaginary numbers. That means what? You can get 3 solutions, but you will have only one real solution. Real, we can say normal. Okay, so as per the equation you will get 3 normals, but you will have only one real normal. Now we'll see the, so we have derived the parabola, tangent and normal equation in Cartesian as well as parametric form. Similarly, we can derive the equation for tangent and normal for ellipse and hyperbola. So I have written the solutions here. It's very easy because the ellipse is x squared by a squared plus y squared by b squared equal to 1. That is the equation. So suppose the Cartesian point is x1, y1. So simply you have to replace the x square by x1, y squared by y1, and rest of the things will be same. This is the Cartesian form.
and if for parametric form, you have to replace x1 divided by a cos theta, y by b sin theta. If you replace that, x cos theta divided by a plus y by b sin theta equal to 1 is the equation. So a will go off, and you'll have 1a in that denominator, 1b in the another denominator. So parametric form, so that is the Cartesian form. Sorry, the tangent equation in Cartesian as well as parametric form. Equation of normal to the same ellipse, it will be a square x by x1 minus b square by b square y by y1 equal to a square minus b square. There is a derivation there. It is very similar to the parabola, where you'll have 2 points on the curve on the parabola. You'll find the secant slope and make 1 point moving to other point, like a q moving towards the p point, like here in the parabola. Where is it? Yes, like moving q to p. So this is the same procedure you need to adapt, so that you will get the slope of the secant line. Okay, slope of the secant line, and then making by 1 by 2 same, and you'll get the slope of the tangent. And with the tangent, if you have the point and slope, so you can find the straight line equation with the point slope form. And coming to the normal, then the slope has to be m1 into m2 equal to -1. That will be used to get the straight line equation for the normal. So that derivation we will do separately, because it will take time. Now we'll see the results only. So I'll make a video for derivation to the ellipse as well as a hyperbola, so that you will understand how the same procedure. So we'll see that in the separate video. So a square x divided by a cos theta. So this is the Cartesian form. A square x by x1 by minus b square y by y1 equal to, this side it will be a square minus b square. So if you substitute x1 y1, you will get ax by cos theta minus by by sin theta equal to a square minus b square, same. So this will be the parametric equation. And for a hyperbola, x square by a square minus b square by y square by b square equal to 1. The same equations, but with a different sign. So if here you have the plus sign, here the plus sign, so here it will be minus sign. So again, if you substitute x1 y1, here the x1 y1 will be for parametric a secant theta, b tan theta. If you substitute that, you will get x secant theta divided by a minus y tan theta by b equal to 1. So this is the parametric form. And coming to the normal form, the same a square x by x1, instead of minus it will be plus here, instead of minus it will be plus, here it will be plus. If you see here, these are the minus, right? So you'll get plus here. A square x by x1 plus b square y by y1 equal to a square plus b square. So to get, this is the Cartesian form. And parametric form, simply substitute a secant theta, b tan theta in the equation. So a will go off, and then ax by secant theta plus by by tan theta equal to a square plus b square. This is what your parametric equation, right? Now we will see condition. We'll see the condition for y is equal to mx plus c. This is a straight line. 2p tangent to the parabola, y square is equal to 4ax. So first we will take the parabola. So let x1 y1 be the point on the parabola. Y square is equal to 4x. That means what? Y1 square. So this point will satisfy this equation, 4a x1. Okay. So tangent means, for this if you have x1 y1, what is the Cartesian form of tangent equation for parabola? it will be y1 equal to 2a x plus x1. So y1 equal to 2ax is 2a x1. So this is equation number 1, and our objective is y is equal to mx plus b tangent, right? So if these two are tangents, then their coefficients are proportional. That means what? Here the y coefficient is y1, the coefficients of equation 1 and 2 are proportional. Then only these two represents the same tangent. That means y coefficient is y1 divided by 1 equal to 2a divided by m equal to 2a divided by c. So 2a x1. So let us equate these two first and then these two next. That means y1 equal to 2a by m, 2a x1 by c equal to 2a by m. That means what? 2a will get cancelled, 2a will go off, then you will have c is equal to m by x1 equal to, what is your x1? C by m, right? So since this is the point, this point and this x1 y1, these are the points in terms of so these 2 points should satisfy the y1 square equal to 4a x1. That means what? y1 is 2a by m whole square is equal to 4a into x1 is c by m. If you see that, you will cancel. Okay, let us expand this. This is 4a square divided by m square, 4a c divided by m. So you will cancel 1m and then you will have 1m. So 4 cancel, 1a will go and another a will go, 1 will be there. That means what? What is your resultant? C is equal to a by m. C should be a by m. So in order to become y is equal to mx plus b is tangent, your C should be a by m. Then the point of contact, your x1 y1 will be, what is your x1 is c by m, and then 2a by m. So since c is equal to a by m, this becomes say a by m into 1 by m, and then a by, this is 2a by m. So this is it. Then your points will be a by m square and 2a by m. So this is the equation, and your equation y is equal to mx plus c becomes y is equal to mx plus a by m. So this is your tangent equation. So your c should be a by m. The point of contact will be this one. So these are the two important results. This is contact point and the equation will be a by m. So since the time is very limited, so results, the derivation part we will do along with the tangent normal to the ellipse and hyperbola derivation. Here the condition for y is equal to mx plus b tangent, y is equal to mx plus or minus root of a square m square plus b square, and the point of contact will be minus a square m by c and b square by c. Similarly, hyperbola, the same minus a square m by c, b square minus b square by c. So here both the minus sign, here one minus and plus b, and you have a square m square plus b square for ellipse, and for hyperbola it will be minus. So these are the things you have to keep in mind, so that when the in examination, if they ask for what is the condition, or what is the point of contact, and what is the equation of tangent for y is equal to mx plus c, you can apply these formulas. Okay, we'll see in the next video the derivation part, and how to simply you can arrive that equation without memorizing. So that is the objective of making these videos. So people should not remember or keep the equations in brain and then and put it on the paper. It's not like that. So people have to understand how these formulas derived, and accordingly people, when you practice 2-3 times, naturally in the examination also you can, it comes on automatically. So thank you, and we'll see with the problems and about the conics, and those problems also we'll solve and put it in the video. Okay, thank you.